Okay, so we're gonna do a summary of the prologue videos, right? So the entire point of the prologue videos were to put everyone in the same space. Uh, yeah, everyone, to put everyone in the same boat, right? So I'm gonna do a quick summary of really like, if you're not into the whole explanation of why these statements are true, I'm just gonna give you what the statements are, right? Like I said before, I can't really make a video of like what steps can you not do, because there's probably like infinitely many of them, right? Instead, I'm gonna give you the steps that you can do, the ones that for sure any teacher should be okay with. So since I'm not gonna do explanations, I'm just gonna tell you, okay, this is what you can do, this is what you can do, this is what you can do. Um, I'm just gonna basically gloss over axioms of real numbers, fractions, inequalities, I suppose. Lots of exponents, and then I'll talk about PEMDAS too. Because again, that last video was kind of a mess. I mean, not a mess, but it was jumbled. It was all over the place. That being said, I would definitely recommend that you watch the fraction video, the about adding and subtracting fractions, and then also the laws of exponents. Just those two standalone ones are a good. I think I was very thorough in those. So and not super complicated. So like I said, because in this video I'm just gonna gloss over everything really. Just give you, this is what you can do, this is what you can do, this is what you can do. And yeah, I don't want this video to be super long, so let's get into it. Okay, so let's see how long this takes, right? Hopefully not that long. So in summary, so what can you do in a math class, right? So we started with the 10 axioms of real numbers. So I'm not gonna write all 10. I'm just gonna write the ones that you kind of definitely need for a math class, right? So for example, uh, let's say, so when it comes to addition, this is why addition is so good. So a plus b equals b plus a, meaning if numbers are being separated by a plus sign, yeah, you can switch them, shuffle them in any way you want, you know. So yeah, I'm just gonna leave that as a plus b equals b plus a. So again, you can shuffle numbers as long as they're there's a plus sign in between them, right? Uh, it's not this doesn't work with a minus sign. Something similar is that a times b equals b times a. So now here though, we're saying, okay, if you multiply two numbers, a times b, like 3 times 5 is basically equal to 5 times 3, right? But what we're saying is, for example, if you had like a, b, c, well, if you shuffle these two, then this is still equal to a times cb. Or if you shuffle these two, they're still equal, cab, So so you can shuffle numbers with a plus sign in between them, or numbers that are being multiplied to each other. You can shuffle them again. All right. What else? What else should we add? The distributive law, very important. So a number times b plus c. Again, parentheses always mean multiplication, really. So a times b plus c equals a times b plus a times c. Now let's move on to more interesting stuff. So what can you do in an algebra class? Well, if two numbers are equal, if a equals b, then you can add the same thing to both sides, and then the quantity should still be equal, meaning that if a equals b, then a plus c equals b plus c. Well, I guess this also works with subtraction, If a equals b, then a minus c is also still equal to b minus c, meaning when you have an equation, an equal signs, you can add the same thing to both sides, and the equal signs remains, or you can subtract the same thing to both sides and the equal signs remains, right? Well, if we're talking about addition, I mean, I guess same thing works for multiplication, If a equals b, then you can multiply on the left, on the right, doesn't matter, right? C times A equals C times B. Or again, suppose that you want to divide, then it also works. A divided by C would still be equal to B divided by C. Alright, so again, if you have an equal signs, you can add on both sides, subtract, multiply, or divide. And the equal sign still remains. Okay, this next one is also important. A plus B times C plus D equals basically this, right? This is how you multiply. So A plus B times C plus D equals to A times C plus A times D, and then now plus B times C, and then plus B times C. I mean, pretty straightforward. Right now, I guess I should add this so that it makes more sense too. You know, again, most of the rules you're gonna see with plus signs, right? But like, you know, what if you had a negative? Like, what if you had for example, what if you had 2 plus 3 times 7 minus 2? You know, suppose you had that, right? What would you do in that situation? Well, in that situation, you should what you always do with negative signs is just think of them, you know, like 7 minus 2 will be the same thing as 7 plus a negative 2, you know. And why is this little distinction so important? Well, because now, right, now you have plus signs, and now you're able to use the rule. Okay, so what am I getting at? I'm getting at is that this should be equal to 2 times 7. I guess I should just write 14. But then now plus 2 times negative 2. You know? And then another plus 3 times 7. And then another plus 3 times negative 2. And then, yeah, from there you can do the math, right? So 14 plus 2 times a negative 2 will be a negative 4. And then plus 3 times 7 will be a 21. And then plus 3 times a negative 2 will be a negative 6. Okay. Well, I mean, yeah, I mean, you just now, I mean, this shouldn't be too bad. You know, 14 minus 4 will be 10. And then 21 minus 6 will be 15. So this is going to be 25 in total. Alright, whatever, right? I'm just saying, you know, even if a rule doesn't have a minus sign, you can still work it, you know, just pass the minus sign to the number that's in front, you know, and that's that, really. Okay, so what else can you do in math? Well, not necessarily something you, that's a mystery, but, you know, basically any negative number, you know, so negative b, right, is equal to basically negative 1 times the positive version, right? Like, again, for example, negative 2 just equals negative 1 times 2. And that might be important in the future, right? Well, something more important is what happens when you multiply a negative with negative. Well, so like if you multiply negative 2 times negative 5, what should the answer be? Well, it actually, the crucial part is knowing this part, that a negative 1 times a negative 1 equals a positive 1, you know. So I'm gonna even circle that one as like a special golden rule, right? Because yeah, so negative 2 times negative 5, right? I just said that any negative number is negative 1 times itself, right? So negative 2 is negative 1 times a positive 2, and then negative 5 would be basically another negative 1 times a positive 5. And what's going to happen is that, again, multiplication, right? Right now you can shuffle these around. So this will be negative 1 times a negative 1 times a 2 times a 5. Well, everybody knows that 2 times 5 is 10, right? And because I'm letting you know that this is a fact, then you will know that negative 1 times negative 1 is a positive 1. So really we have positive 1 times 10 is just 10. Right? Well, I mean, I guess I should say that as well, right? Any number times 1 is itself. So 1 times any number a will be itself, right? A. What else? I mean, I guess something similar, right? Any number plus 0 is, again, itself, right? And then what else? Okay, this one says a little bit special. 0 times any number is 0, right? I guess I should circle all of them. Now, as far as axioms of real numbers, these are the main ones that have to do with equalities, right? So, if you're solving an equation, now you know you can add, subtract, multiply, divide by both sides, and you still remain the equal signs, right? Okay, but then now we have, let's say, inequalities. So this one will be a little short. I mean, you can always try to find the longer version video. But let's start with some things, right? So if x is less than y and y is less than z, then it has to be that x is less than z, right? I mean, what the only thing that a less than sign means is that if you were to look at numbers in a number line, right? So you know, zeros right here, 1, 2. Like if I'm saying that x is less than y, all I'm saying is that somewhere in this number line, x is on the left side of y. Like, you know, maybe x is here and then y is here, you know, or maybe y is right here, or then maybe y is right here. That's what it means for x to be less than y. That x is on the left side of y, or similarly that y is on the right side of x. You know, so I'm saying that if x is less than y and y is less than z, then x is less than z, right? So that's a totally legitimate argument to make in a math class, right? All right, what's another one? If x is less than y, then if you add the same thing to both sides, it doesn't even have to matter if it's positive or negative. If x is less than y, then x plus any number, really. X plus z will still be less than y plus z. So again, if you add the same thing, and again subtract, so it's the same thing with subtract. If you add the same thing or subtract the same thing, I'm saying that the inequality still remains. If it's less than, then it's less than. If it's greater than, then it's greater than. I mean, what? Let's add another one. Let's do something similar. What about multiplication, right? If x is less than y, and if c this time is a positive number, doesn't matter what number as long as it's positive. If x is less than y and c is a positive number, then if you multiply it to both sides, again, lucky thing, the inequality remains. So c times x is still less than c times y. But again, it has to be that c has to be greater than 0. Well, the reason why I'm saying that is because with negatives, it does the opposite, right? So a little short one is right here. If x is less than y, then negative x is actually greater than negative y. And again, let me do an example of this one, because this one might be a little tricky to see right away, right? But I'm saying, if for example 2 is less than 5, right? But if you agree that 2 is less than 5, then you also have to agree with me that negative 2 is greater than negative 5. And again, negative 2 greater than negative 5 is another way of saying negative 5 is less than negative 2. And remember what I was saying about, you know, what does the less than inequality mean? Yeah, it means that negative 5 in a number line, if we had a number line, 0 is going to be right here, and negative 2 is going to be right here, but negative 5 is going to be right here. So as you can see, right, negative 5 is more to the left than negative 2. That's why negative 5 is less than negative 2. So yeah, that's one way to say that, right? Well, you know, I'm saying that if you switch the signs, then you also kind of switch the inequality, right? Well, I'll do something even more general. If x is less than y and this times c is negative, meaning, so yeah, less than 0. If x is less than y, but then this time c is less than 0, then kind of same thing happens over here. Then c times x is gonna be greater than c times y, meaning you because again, just think of c like a negative number, right? -2, -3, right? If you have two numbers where this is less than that and you multiply it by -3, you will see that -3 times x should be greater than -3 times your y, no matter what x and y are. Alright, I think we're making kind of good time, so let's move on. That's all I want to say about inequalities. Okay, I want to mention fractions real quick. And honestly, the video that I made about fractions, you know, the standalone video I made about fractions, I think it's pretty good. But if I were to summarize, I would say this. Okay, what were the highlights? Well, multiplying fractions is super easy. I always want you to remember that, right? So a over b times another fraction c over d is just equal to, basically, you multiply the top with the top and the bottom with the bottom, and that's how simple it is to multiply fractions. Okay. Now, technically speaking, okay, if you wanted me to give you a formula about how to add fractions, so a over b plus c over d, how do you add fractions? Well, I guess the formula is this: a times d plus b times c over b times d. You know, that would be the formula. But really, if you watch the video, you'll see that my point is, you know, as long as two fractions have the same denominator, you know, so like p over r plus q over r, you know, as long as they have the same thing on the bottom, then you can freely, willy-nilly just add the tops. So p over r plus q over r would just be p plus q over r. So meaning adding fractions is also easy, but only if they have the same denominator, right? So again, if you go back to the video, like I said, I think I did a good job at explaining that. Now, anytime I give you an equality sign, like I did over here, notice that equality signs actually work both ways. But in this particular case, I'm just gonna spell it out too. You know, I'm gonna write the same thing again, just backwards, right? If you have a p plus q over r, this is equal to p over r plus q over r. The reason why I point this out is because, yeah, you know, like maybe you're doing an algebra class where you have you know, I don't know, 2x plus 4 equals 8, whatever, right? And you say, okay, I want to divide by 8. No, not 8. I want to divide by 2, let's say. Because 2 happens to be, 2 goes into 2, 4, and 8, right? So suppose you want to divide by 2. So you have to divide 8 by 2, but then you also have to divide this whole thing by 2. Well, what I'm saying is that, yeah, you can actually split up like 2x. Well, I mean, you split them up with, you know, from the plus signs, right? So the plus sign is right here. And what I'm saying is that if you have 2x plus 4 divided by 2, it's completely okay to write 2x over 2 plus 4 over 2. I'm saying that it would be correct to write it that way. And if you can, anyways, whatever. Okay, I'm just pointing this out because I want you to remember that this one, however, this is definitely not legit. This is never okay. If you had, for example, a fraction that was a divided by b plus c, right? This is never do this in class. This is not going to be a over b plus a over c. Never. So even though I did say, you know, I'm not going to tell you what not to do, this is definitely a common mistake that you should never do. Okay? And I guess the last thing to mention about fractions is this one other thing, right? Well, we added fractions, we multiplied fractions. I mean, you can imagine how easy it is to subtract fractions, but what about divided fractions, right? A over b divided by, I mean, you have fractions, and on top of that, you're dividing even more, right? Well, actually, this quantity, a over b divided by c over d, is just equivalent to a over b times, basically flip them. Flip the fraction you're dividing by. D over B. Alright. So that's how you divide fractions. This is the manner in which you divide by a fraction. Alright. I think we're almost done. We're almost done. It's not going to be a gigantic video, this one. Alright, so what I want to talk about next, I want to talk about exponentials, let's say, right? So, you know, just a quick refresher. What's an exponential mean? A to the power n just means a times a times a times a total of n times, right? You know, like I said, you know, a to the power 3 just means a times a times a, you know, 3 of them, right? Simple as that, right? Well, like I said, I did a lot of videos to show you that, you know, these don't even have to be nice numbers. It could be fractions. This could be irrational numbers. But then these following rules still apply. So, for example, let's say a to the power n times a to the power m equals a to the power n plus m. Okay, that's one rule, or that's one law, I should say. I mean, it just means, you know, if you have a squared times a cubed, so meaning you have 2 a's and then you have 3 a's, so in total you're gonna have 5 a's. A squared times a cubed is just a to the power 2 plus 3, which is a to the power 5. You know, that's what this rule means. Okay. Well, I suppose that the next one that's very similar is this other one, right? Instead of multiplying, you're dividing. So 8 over to the power n divided by 8 to the power m. Well, this one is actually could be two things actually. This could be either a to the power n minus m. However, it can also be 1 over a to the power m minus n, so backwards. Alright, so why could it be one or the other? Well, let's say for example that you had, you know, a to the power 5 divided by a to the power 3, right? Well, this means that you have 5 a's on top of the fraction, but then you only have 3 a's on the bottom, right? So this one cancels with this one, this cancels with this, and this cancels with that. You end up with only 2 on the top, right? Meaning a squared. But this is the same thing as basically a to the power 5 minus 3 to begin with, right? Now, suppose in the other case, you would have started with a fraction where, like, let's say it's a to the power 4 on the top and a to the power 7 on the bottom. Right now, the power on the bottom is bigger. Well, okay, you have 1, 2, 3, 4, and then you have 1, 2, 3, 4, 5, 6, 7. So again, this cancels with this with that one, this one with this one, this one with this one, and you end up with just 1 over 8 to the power 3. But again, notice that 1 over 8 to the power 3 just also happens to be 8 to the power 7 minus 4. It's not a coincidence, it's this rule, basically. Alright? And yeah, so your teacher usually wants your powers to be positive, you know, like you could say your answer is 8 to the power negative 3, and that will be okay. But, you know, I don't know, for some reason some teachers tell you, okay, your powers have to be presented as positive powers for some reason. Okay, so that's 1. This is 2 in 1, so that's 3. There's 6 laws in total. So which one am I missing? I guess this one's like the one that was kind of a big deal for me. A to the power n then raised to the power m equals a to the power n times m. Right? So it's like saying, you know, suppose you had a squared raised to the power 3, right? Well, this 3 means that you have a square, right? That's what that means, you know. A squared to the power 3 just means that you have a squared 3 times. But then you have a squared 3 times, so you have a. So then how many a's are you going to have in total? How many a's are you multiplying? You're multiplying 6 of them, so this should be a to the power 6. And again, it's no coincidence that 8 to the power 6 is basically 8 to the power 2 times 3. See? Again, these are all easy to explain with when the numbers are nice, right? But I'm saying that actually, even if the numbers are not nice, these rules still apply. Okay, this one's also pretty big. A, B, so you suppose you have two numbers inside of parentheses, and you're raising this parentheses to some power n. Well, it actually means that this is equal to a to the power n times b to the power n. Again, a little example will be, suppose that you have 2 times 3 to the power 4. So what does that mean? You have 2 times 3 4 times, right? 2 times 3, 2 times 3, 2 times 3, right? And again, it's multiplication, so actually you can just shuffle multiplication all around. I mean, when I mean that, I mean this, right? 2 times 3, and then 2 times 3, then 2 times 3, then 2 times 3, right? So yeah, if I write it this way, right, I can shuffle them around, right? Well, if I shuffle them where, like, I just put all the 2's on the left side and I put all the 3's on the right side, I'm going to end up with 2 times 2 times 2 times 2 4 times, and I'm going to end up with 3 times 3 times 3 times 3, right? Well, this just simplifies as 2 to the power 4 times 3 to the power 4, and that's exactly what this rule says, right? So 2 times 3 to the power 4 should be equal to 2 to the power 4 times 3 to the power 4, meaning a times b to the power n should be a to the n times b to the n. And basically, I mean, the other one that's basically the very analogous is a over b to the power n should be a to the power n times over b to the power n. Well, because again, suppose again, same thing, 2 and 3, right? If you have 2 over 3 to the power 4, then you have 2 over 3, 2 over 3, 2 over 3, 2 over 3, right? Multiplied. And what did I say about fractions? The nice thing about fractions is that you just multiply tops with the tops, bottoms with the bottom. So I'm going to have 4 2's in the top, and I'm going to have 4 3's in the bottom. Right? Okay, so those are the laws of exponents. And then the last thing that I should say, okay, I mean this one's kind of just added last minute, right? But PEMDAS, right? If in case you're having trouble, what does PEMDAS mean, right? Okay, well the P just means parentheses, but what does that actually mean? So parentheses just signal. So parentheses. I guess I should use the plural version. They just signal. The order of operation, meaning order of operation, maybe. Meaning, for example, like, suppose I had a problem, right? X plus 5 multiplied by 2, and then plus 3 minus x, I don't know. And then suppose that I need to add 7 to this. And then for some reason I need to square it. But then after I square it, I subtract by 11, so another parentheses. And after I subtract by 11, I still multiply it by 5, right? Well, what the P in PEMDAS just means that, just look at your, if for some reason you had this and then your teacher said simplify this, right? Again, you see how I started with these inner parentheses first? That means that I most likely have to deal with those first. So what I would do in this situation is I would trace back. So just trace back the parentheses. So for example, okay, these two parentheses are sticking out, so these two are together. Okay, so then but again, I have to take care of the most inner parentheses, right? So again, okay, this is the next parenthesis on the left side, and what's the next parenthesis on the right side? This one. Okay, so then those two are together. And then again, okay, this is the next parenthesis from the left. What's the next parenthesis from the right? I guess this one, right? And then now look, we have a funny thing here. Notice that in this parenthesis, right, there's actually two parentheses in the beginning, right? So PEMDAS just tells you, okay, inner parenthesis first. So which one do you do? Do you do this one first, or do you deal with this one first? Actually, at this point, it doesn't matter. Just choose one. But yeah, I mean, this helps me to a lot with parentheses. You know, just like color them, the outer ones, and then that way it's kind of easy to track. Okay, I got to start from the inner, from the very inside. Okay, so that's the P from PEMDAS. The exponents. Well, the only thing I want you to remember is that numbers of distinct powers don't interact really, or you can't really mix them, you know. All right, numbers of distinct exponents don't quite mix, let's say. I mean, again, I think example shows better what I'm trying to say. For example, I'm saying that if you have a 2 times x plus 5 squared, you know, this I will see this as like, this is a package, you know, or yeah, like maybe you're receiving a gift. But then if there's a power that's not 1 here, right, it's like a ribbon, and like you can't really reach for the gift inside the package unless you undo the ribbon, right? So what I'm saying is that this 2 cannot interact with the inside of this package unless you get rid of this square somehow. Meaning this is definitely not equal to 2x plus 10 squared. Okay, so for example, or in a similar note, if you have 3 times 4 to the power 2, this is definitely not equal to 3 times 4 is 12, right? This is definitely not equal to 12 squared, right? So that's kind of what I mean about, like, you know, that's like the only thing that to watch out. You know, you gotta undo the power before you actually interact with the other numbers. The M and the D from PEMDAS, multiplication division. Well, the only thing I would say about the multiplication division is that just think of them as glue. So multiplication and division are like glue. So for example, you know, let's say that you had a 3 plus 16 divided by 2, and then I don't know, plus 8, right? So remember when I said about like things with addition, right? You can shuffle them around. Well, you can shuffle them in this. You can shuffle them many ways, but these two need to stay together, like glue. So you can shuffle it. You know, you can shuffle it as like 3 plus 8, but then again 16 divided by 2, they gotta stick like glue. Or you know, maybe you want to shuffle these two over here, and that's okay too. 16 divided by 2 plus 8 plus 3, that's also fine. But again, when two things are being multiplied to each other or being divided by each other, they're like glue, you know. Other than that, yeah, you can still shuffle things around. And then lastly, addition and subtraction. Again, from PEMDAS, right? Well, again, yeah, shuffle anywhere you want. But with the minus signs, right? You gotta take the negative with you. Take the minus with you. So take the minus with you. So you know, again, in this little space that I have left, if you had, you know, 8 minus 3 plus 5, I don't know, minus 2 plus 7, right? So yeah, again, it's definitely okay to shuffle things around. It's just that this negative 2 better stay negative 2, and this negative 3 better stay negative 3. So for example, I don't know, you can shuffle it as like 7 plus 8, minus 3 minus 2 plus 5, right? All I did was shuffle, right? But again, as long as you keep the negatives where they're supposed to be, you're fine. I mean, what's another way to shuffle this? I don't know. Like maybe you put the -3 at the front, and that's kind of fine too. -3 plus 5. I don't know, plus 8 minus 2 plus 7. Again, all I did was shuffle, right? And again, as long as the 3 and the 2 stay negative, yeah, that's completely okay to do. All right, so those are like all the things that you are allowed to do in the math class. This is, I guess I don't want this to be 40 minutes, so I'm gonna end it. But yeah, I just basically summarized like 16 hours of video in 37 minutes. So I think that's pretty good. Yeah, those are the things that you are allowed to do in any math class. If there's another thing that you think, oh man, I wonder if I can do this, yeah, feel free to comment below, and then I can tell you. But it's even more interesting if you can answer that question yourself, you know, with some mathematical logic and whatnot. But okay, like I said, I'll end it here before this video is bigger than it needs to be. See you later.